Hello everyone, welcome to the SR Maths Learning channel. Today in this video we are going to discuss the sets chapter. So let's see what is the definition of sets. So sets definition is collection of well-defined objects. Collection of well-defined objects is defined as a set. So what is meant by well-defined objects here? What is meant by well-defined objects? Let's try to elaborate this. So let's see one example. How can we tell that well-defined collection of objects? So if I'll ask one question like vowels in English alphabets. Vowels in English alphabets. So whomever we will ask vowels in English alphabets means, so they'll tell A, E, I, O, U. So these are the vowels in English alphabets. So whoever will ask the question, the answer never changes. So this is well defined. This is well defined means from person to person. So answer will not change. So whomever we will ask vowels in English alphabets means they will tell A, E, I, O, U. So if we will write that in a flower bracket, so we can call it as a set. We can call it as set. So let's see another example like 5 best batsmen in Indian cricket team. 5 best batsmen. 5 best batsmen in Indian cricket team. So if you look at this example, in Indian cricket team, if we'll ask some X person, so they will tell whom they like, they will feel the best cricketers. If I'll ask some Y person, so they will tell some different answer, best 5 whom they like. So the question and its answer changes from person to person. So this is not well defined. It is not well defined. So well defined in the sense, so whenever, wherever. So the answer should be same. The answer should be same. So that's why sets we can define like collection of well defined objects. Collection of well defined objects. So this is the definition of sets. So here we have different types of sets. So one is single among that singleton set. So what is mean by singleton set is a set consisting of only one element. The best example what we can say for this one is set of even prime numbers. Set of even prime numbers. So what are the even prime numbers we have? So only two is the set of even prime numbers. So we can write like this. So in this set, only one element and a set consisting of 0 as one element. So this is also example for singleton set. So like this, the set which consists of only one element is called a singleton set. Next, finite sets. So what is meant by finite set? So for example, if I'm taking a set of natural numbers less than 20. So if I'll take like this, so 1, 2, 3, 4 up to 20 we have in this set. So where or and in which set we can able to tell how many number of elements are present. Those kind of sets are called finite sets. Generally, sets can be denoted with this symbol flower brackets, and all with the capital alphabets we will write the name for the set. So in a set where we can count the number of elements is called a finite set. So set of prime numbers, another example, set of prime numbers less than 20. So what are the set of prime numbers less than 20? Like 2, 3, 5, 7, 11, 13, 17 and 19. So these are the set of prime numbers which are less than 20. So like this we can take the example for finite set. So coming to the infinite set, so same set of natural numbers I can take like this. So like 1, 2, 3, 4, so on up to infinity. So here the number of elements we cannot count. The number of elements we cannot count because it is we are given up to infinity. So up to infinity means we don't know where it will end. So these kind of sets are called infinite sets. So these kind of sets are called infinite sets. Next, cardinal number of a set. So what is meant by cardinal number of a set? So I will take one small example here. So let's take the example like A is equal to 1, 2, 3, 4, 5, 6 we have, and we have another set B is equal to some 3, 4, 6, 7 like this. So if I'll ask you, so how many number of elements are present in set A? So in the set A we have 6 elements. So this 6 number is called cardinal number. Cardinal number of this set A. Cardinal number of set A we can say. So similarly, if I'll ask you how many number of elements are present in the set B. So how many number of elements are present in set B? So there are how many number of elements? Only 4 elements are there. So that's why n of B is equal to 4. So here this 4 is called the cardinal number of set B. So next, equal sets. So what is meant by equal sets? So if you'll consider two sets A and B, when they can call it equal is if every element of set A is an element of set B and every element of B is an element of set A. That means both should be having the equal number of elements and same elements like 1, 2, 3, 4. And some B is also some 3, 4, 1, 2. So here number of elements are same, 4 elements, and the elements present in the set also same. So these kind of sets are called equal sets. These kind of sets are called equal sets. Next, equivalent sets. So when we can say equivalent sets means, we can take the same example like 1, 2, 3, 4. So here cardinal number of this set A is 4. So if you look at this one, here cardinal number of set B is like let's take A, B, C, D as the elements. So cardinal number of this set is also 4. So if you look at this, here cardinal number is same, but the elements present are not same in this. So the sets in which n of A is equal to n of B. So means if sets will assume like A and B, if its cardinal numbers are same, that means the number of elements present in the sets are same, then we can say those are equivalent sets. So clearly we can say from here that every equal set, I mean equal sets are equivalent. But converse of this, but equivalent sets we cannot say that equal. We cannot say equal. Equal sets are equivalent, but equivalent sets may not equal. I mean need not equal, may not equal. And equal కావాల్సిన అవసరం లేదు అని. So generally equivalent sets is denoted with this symbol. If you will take A and B are two sets, if they are equivalent, we can say that A is equivalent to B. So this is the way how we will represent equivalent sets. So next comes to subset and supersets. So what is meant by subset? What is meant by superset means, if I'll take a set A like 1, 2, 3, 4 up to 10, and another set I'll take like 3, 1, 3, 5, 7, 9. So if you look at here, every element of B present in this is element present in the A. So what I mean is, all the elements of B are present in all the elements. I mean elements in A. So all the elements of B present in A. So this then we can say that B is a subset of A. B is a subset of A. So here we can say that A is a superset of B. So this is called as A is a superset. This is the subset symbol. This is a subset symbol, and this is a superset symbol. Superset symbol. So here clearly we are given that the set B is said to be subset the set B is said to be subset of A if every element of set B is also an element of set A. So symbolically, this is the way how we will take. So here this this one is called superset, and this is the subset symbol. So what is mean by proper subset? What is mean by proper subset in this? So if you look at this, B is a proper subset of A if every element of B is an element of A and there is at least one element in A which is not B, which is not in B. So see here, B is here, we can say proper subset. B is proper subset because 1, 3, 5, 7, 9 are there in the set A, but 2, 4, 6, 8, 10 are extra sets. So this is called proper subset. So in subset, particularly it is called a proper subset. So generally, how many number of subsets we can take? So if you look at the, see, a simple example I'll take generally. So here, before going to subset, first we have to discuss that what is meant by null set. So null set is a set in which there is no elements. Generally, it is denoted by phi, and symbolically we can take like this: phi is equal to empty set. So by mistakenly, if you'll keep 0 in this, and if you're saying this is a null set, that is wrong, because here one element we have 0, so then we cannot say this as null set. So null set is a subset of every set. Null set is a subset of every set. So if I'll take any set, non-empty set A, like 1, 2, 3, so how can we write the subsets for this? How can we write the subsets for this? So 1 is a subset, 2 is a subset, 3 is a subset, and 1 comma 2 is a subset, and 1 comma 3 is a subset, 2 comma 3 is a subset. And phi is, I mean, null set is a subset of every set, and a set is a subset of itself. So here, if you look at 1, 2, 3, 4, 5, 6, 7, 8. So total 8 subsets we have, so that we can write like 2 cube. So if I'll take the another example, just simply AB. So AB. So if you will see AB, here subsets will be like A, B, and A comma B, and the null set also subsets. Total 4 means 2 square. So in general, if your set has n elements, number of subsets will be 2 power n. 2 power n subsets are possible for a non-empty set. So let's see next what is power set. So power set is a set which is formed by all the subsets. So for example, we are assuming 1, 2, 3. This is a set. So what is the power set of this A means? It is denoted by P of A. So what is the subsets we have for this? 1 is a subset, 2 is a subset, 3 is a subset, and 1 comma 2 is a subset, 2 comma 3 is a subset, and 1 comma 3 is a subset, null set is a subset, and 1 comma 2 comma 3 is a subset. So if these all the 8 subsets we are taking the elements for this, then we can say this is the power set. So the elements of power sets will be subsets of the given set. So like 3 and 1 comma 2 is an element, and 1 comma 3 is an element, and 2 comma 3 is an element, 1 comma 2 comma 3 is an element, and 5 also an element in power set. So this is called a power set. Usually it is denoted by P of A. So how many number of elements will be there in the power set? Number of elements in a power set is equal to 2 power n. That is nothing but number of subsets of a set. So hope you understand this power set. Next, universal set. What is meant by universal set? A set containing all the elements under consideration. So means how many subsets we will take, that all subsets and even extra elements also can be there in the universals. This is like a mother set for all the sets. So universal set usually denoted with U or X, and there is another letter with what in some textbooks with mu. So this is universal set. So let's see disjoint sets. what is meant by disjoint sets? If I'll take any two sets like set A is a collection of even numbers, So we can take like 2, 4, 6, 8 positive even numbers, 5, 6, 8, and so on. And B set I'll take odd numbers, collection of odd numbers. So if I'll take, I'll get like 1, 3, 5, 7, 9. So is there any common element for these two? There is no common element, zero common elements in A and B. So these kind of sets are called disjoint sets. These kind of sets are called disjoint sets. Means if in any sets, if any two sets, there is no common element, if there is no common elements, so that kind of sets are called disjoint sets. So generally disjoint sets, we can take the condition like this: A intersection B. Intersection, it means here common elements in both the sets. So there is no common elements, means we can say A intersection B is a null set. When two sets satisfy this condition, that kind of sets are called disjoint sets. So let's see what is the operation on sets. So operation on sets, there is two kind of operations. One is union of two sets, and another one is intersection of two sets. So let's see what is union of two sets. Union means simply there is a meaning in the topic. The number of elements present in A and the number of elements present in B, all we will write together. Those kind of set is called union of two sets. Generally, the union of sets denoted with a symbol like this in U shape. So for two sets A and B, we can take like A union B. We can read it as A union B. So let us take example. A is 1, 2, 3, 4, 5, and B is 3, 4, 6, 8. 3, 4, 6, 8. So A union B, how can we find this? 1, 2, 3, 4, 5 union 3, 4, 6, 8. So if I'll take these two union, so 1, 2, 3, 4, 5 we have in the first set, and 3, 4 is present in the second set also, but no need to write twice. If we will write once, it is enough. So 5, and extra elements in the B is 6, 8. So this is A union B. This is A union B. So how can we write A union B? Means like this. So next, intersection of two sets. Intersection of two sets. What is meant by intersection of two sets? It is nothing but the common elements present in the both the sets. So if I take first two set as set A as 1, 2, 3, 4, 5, set B as 3, 4, 6, 8. So intersection means it is denoted with this symbol, reverse of U. A intersection B, we can call it as. So 1, 2, 3, 4, 5 is the set A. Intersection 3, 4, 6, 8. So what are the common elements present in the both? 3, 4. 3, 4 are the common elements. So if you take that 3, 4 as the one set, this is called a intersection of A and B. This is called intersection of A and B. So here we have actually Venn diagrams. So diagram, what is meant by Venn diagram means the pictorial representation or the diagrammatical representation of sets is nothing but Venn diagrams we can call. Let's see the universal set we can take with the square box or rectangular box, and the sets in this we will consider with circles like this. So let's think this is the set A, and another set B is like this. So this is the set B. So set B, let's take like this. So if you look at how to represent this is A, this is B. So A union B means this total, the A union B means this total shaded part is called A union B, means the elements present in A, the elements present in B. So this total part is called A union B. So diagrammatically by using the Venn diagram, so how we will represent this A union B like this. So if you take the elements in this, so what are the common elements in both 3, 4? So 3, 4 we will write here, and 1, 2, 3 will be here, and extra elements in B is 6, 8. So this is the way how we will represent A union B. So here this shaded part is taken as A union B. So this is called a Venn diagram. So this is called a Venn diagram. So for the A intersection B, how we will take this? For A intersection B, how we will take the Venn diagram is, so let's see, this is a universal set, and we have two sets like A and B. So let's represent with circles. So let's represent with circles. So another one, set B is like this. So A intersection B here. So A intersection B means what? This is A, this is B. So this is the part which we can say A intersection B means the common elements in both. The common elements in both. So this is A intersection B. So this is the way how we will denote the Venn diagram for A intersection B. Okay. So next, how can we find the difference of two sets? So how can we find the difference of two sets? So let's take example here. A is equal to 1, 2, 3, 4, 5, 6. So let's consider the B as some 5, 6, 7, 8, 9. So how to find A minus B? How to find A minus B is, so let's write 1, 2, 3, 4, 5, 6, the elements present in A, and let's write the elements present in B. So 1, 2, 3, 4, 5, 6, and 5, 6, 7, 8. So let's cancel the elements which are present in both, that is 5, 6. So the remaining elements present in the first set is nothing but A minus B, that is 1, 2, 3. So after cancelling the common elements in both, the remaining elements only in first set. So if I want to take B minus A from here, so B minus A, how I will take? So first B I should write, that is 5, 6, 7, 8, 9. So minus A is 1, 2, 3, 4, 5, 6. So if I'll cancel the common elements, so what are the left out elements in first set is 7, 8, 9. So this is the B minus A, how we can find. So I mean, by using Venn diagram, so how can we present this? So if I'll take universal set like this, so let's take the set A. Let's take the set A here. This is set A, and let's take the set B. So this is the set B. Set B. So here A minus B. So if this is a set A, this is set B, and this is universal set total. A minus B means from A after removing the B. So this is the part left out. So this is the part left out. So this is A minus B here. So this is A minus B. So I'm coloring this. So which is A minus B. So this is the A minus B. So the part which is A minus B. A minus B. So this is the A minus B. And I'm coloring with another color, which is B minus A. So this is the B minus A. So this is the B minus A. So this is the part B minus A. So here very clearly we denoted this green color. Green color is A minus B, and this is the B minus A. B minus A. So A minus B and B minus A, how to take, we just now see. Next, let's see what is the next topic is the symmetric difference of two sets. So what is meant by symmetric difference? Generally, it is denoted by delta. So A delta B, we have formula like A minus B union B minus A, or A union B minus A intersection B. So what it means is, if I'll take one example, 1, 2, 3, 4, 5, and another one is B is 3, 5, 7, 9. So how can you find A delta B is? So A delta B is A minus B union B minus A. This is the one way. And another formula is for A delta B, A union B minus A intersection B. So this is also the way to find out the symmetric difference. So let's see in the both the ways how to find out. So first A minus B is what? A minus B is what? 1, 2, 3, 4, 5 minus 3, 5, 7, 9. So in both 3, 5 is cancelled. So A minus B is 1, 2, 4. And in similar way, how can I find B minus A is 3, 5, 7, 9 minus 1, 2, 3, 4, 5. So this is 3, 5 is cancelled in both. Then remaining elements are 7, 9. So this is the B minus A. So now symmetric difference between A and B is A minus B union B minus A. A minus B union B minus A. That means 1, 2, 4 union 7, 9. So what you will get the symmetric difference is 1, 2, 4, 7, 9. So this is the A delta B. This is the A delta B. So another way to find out is first to find the A union B. So how can you find the A union B? 1, 2, 3, 4, 5 union 3, 5, 7, 9. So the union of these two is 1, 2, 3, 4, 5 and 7, 9. So this is A union B we will get. And A intersection B, what we will get in these two? So 1, 2, 3, 4, 5 intersection 3, 5, 7, 9. So this is equal to in the both the common elements are 3, 5. So if I'll take symmetric difference between these two, so you'll get 1, 2, 3, 4 minus right 4, 5, 7, 9 minus 3, 5. So 3, 5 is cancelled in both. So the remaining elements are 1, 2, 4, 7, 9. So look at the answers. So look at the answers what we got in the both the cases. So 1, 2, 4, 7, 9, 1, 2, 4, 7, 9. So to find the symmetric difference of two sets, we can find either this formula or we can find by using this formula. So this is the way how to find the symmetric difference. So let's see what is the complement of a set. So let's take one example. So that universal set I will take, which is defined with the elements 1, 2, 3, 4, 5 up to 10. So I'll take a subset of this A, subset of this U as A. So that is 1, 3, 5, 7, 9. So generally the complement of A is denoted with A power C or A dash also. So how can we take this A complement is U minus A. Means the subset A we should subtract from the U. We have to take the difference of U and A. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 minus 1, 3, 5, 7, 9. So this is equal to in both what are the common elements we can collect 1, 3, 5, 7, 9. So 1, 3, 5, 7, 9. So the remaining elements of A complement will be 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. This is the how to find the complement of a set. For example, if I found the complement of a complement, means A complement, whole complement. So what I'll get, that is nothing but U minus A complement. So that means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 minus A complement is 2, 4, 6, 8, 10. So if you'll remove these common elements, in both, so the left out in the first set is 1, 3, 5, 7, 9. So which is nothing but our set A what we took, right? So by this what we can say A complement whole complement is equal to A. So like this we have few properties. To know about the complement. So complement of a set. So let's see that properties of complement of set. So properties of complement set. Sets. Properties of complement sets. So let's see the first one is complement of universal set is null set. Complement of universal set is null set, and complement of null set is universal set. And next, A union A complement is universal set, and if you take intersection of the A and A complement, that will be null set. If I'll take any set and its complement and whole complement will be a, just now we saw. This is called a law of double complementation. Law of double complementation. Law of double complementation. So we can call it as law of double complementation. Next, A union B whole complement can be written as A complement intersection B complement. And reverse also we can write like A intersection B whole complement is A complement union B complement. So this is called De Morgan's law. De Morgan's law. So these are the different properties of complement of a set. So here we have some important results on cardinal number. So let's see that important results on cardinal numbers. So that is some important results. Some important results on cardinal number. On cardinal number of sets. So let's see in this first one, n of A complement is n of U minus n of A. N of A complement is n of U minus n of A. So using the Venn diagram, so how can we see this is, let's think this is the universal set, and this is our set A. So in this, so if you see what is A complement is except this area, so remaining complete is A complement, means so from this total square blocks, if you remove only this yellow color, we'll get n of A complement. So this is total. This total is n of A complement. So that is what we are written here. Next, point number 2. So n of A union B is equal to n of A plus n of B minus n of A intersection B. So let's see how this is correct. So how this is correct. So if I'll take the set A as 1, 2, 3, 4, 5, 6, set B is 5, 6, 7, 8. So if you'll find out A union B, our A union B will be like this: 1, 2, 3, 4, 5, 6 union 5, 6, 7, 8. So what is the union of these two sets? What is the union of these two sets? 1, 2, 3, 4, 5, 6, 7, 8. So we should write only once if the numbers are repeating. So A intersection B is what? Only 5, 6 is the A intersection B. If you look at the cardinal numbers of this all, n of A will be, we are having the 6, n of B we are having the 4, and n of A union B from here, n of A union B we have 8. N of A union B we have 8, and n of A intersection B, n of A intersection B we have only 2 elements. So if you'll see very clearly, add these two, means n of A plus n of B. If you'll add the 10 and subtract from that n of A intersection B, that is equal to 6 plus 4 minus 2, which is 8. So this is nothing but n of A union B. This is nothing but n of A union B. So this is the way how we can say n of A union B is equal to n of A plus n of B minus n of A intersection B. So next, result 3. Result 3. So what is the result 3 is? N of A union B will become n of A plus n of B. So when A and B are disjoint sets, A and B are disjoint sets. Why? What is mean by disjoint sets is where A intersection B is equal to null set, means there will be no elements, means A intersection, n of A intersection B will be 0. So when you will substitute the n of A intersection B, that is in the formula n of A union B is equal to n of A plus n of B minus n of A intersection B. In the case of disjoint sets, this is 0. So obviously we'll get n of A union B is equal to n of A plus n of B. So this is the result 3. So result 4. So n of A minus B. So how can we represent this also as n of A intersection B complement? So how can we write n of A intersection B complement? So let's see. So this is our universal set. So where we have two sets A and another set is B. So another set is B. So this is A, this is B. Let's think. Okay. A minus B. A minus B means this part only. So A minus B is this is the part which is A minus B, which already we saw when we are discussing the concept, starting concept. This is A minus B. So how we are getting the A minus B here from the total A, means from n of A. If you remove this intersection part, you will get n of A minus B, means n of A minus n of A intersection B. Or another way, how can we say from n of A union B, means from this total, if you are removing the B, that is also nothing but n of A minus B. So this is the way how we will understand this one. So next, result number 5. So what is the result number 5? N of B minus A. So just now we discussed the 4. So in the same way, n of B minus A is n of A complement intersection B, where we can write n of B minus n of A intersection B, or that equal to n of A union B minus n of A. So next, result number 6. N of A complement intersection B complement can be written as n of A union B whole complement. That is nothing but n of U minus n of A union B as per the first formula. So next, formula number 7. N of A complement union B complement. We can write n of A intersection B whole complement, which can be written as n of U minus n of A intersection B. So when we are taking the 3 non-empty sets, then n of A union B union C, how can we find this? N of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of C intersection A plus n of A intersection B intersection C. So this is the formula to find the union of 3 sets. So let's solve the problems. So this is the first question. Examples: if n of A is equal to 28, n of B is equal to 32, n of A in union B is equal to 50, then find out n of A intersection B. So let's see given data. First of all, what is the given data is n of A is equal to 28, n of B is equal to 32, n of A union B is equal to 50. So they're asking to find the n of A intersection B value. So we have formula n of A union B is equal to n of A plus n of B minus n of A intersection B. So let's substitute the values in this. 50 is equal to 28 plus 32 minus n of A intersection B. So from here we will get n of A intersection B is equal to 28 plus 32 is 60, 60 minus 50. So therefore n of A intersection B will be 10. So this is the way how can we solve the problem. So if n of A is equal to 50, n of B is equal to 20, and n of A intersection B is equal to 10, then n of A delta B in the sense here they are talking about the symmetric difference. So symmetric difference, how to find the symmetric difference. So let's see what we have information first. So given data is n of A is equal to 50 we have, n of B is equal to 20 we have, n of A intersection B is 10 we have. So if I look at the formula of n of A symmetric difference B, we have two formula. One is A minus B union B minus A. Another one is n of A union B minus n of A intersection B. So I'm going to use this formula here because they are already given n of A intersection B. So I will find out n of A union B. So how can I find out n of A union B? N of A union B is n of A plus n of B minus n of A intersection B. So from here, this one is 50 plus 20 minus 10. So what we will get 60 as the n of A union B. So that we will substitute in the formula here. So we will get symmetric difference of A, B is 60 minus 10. So therefore, n of A symmetric difference B is 50. So this is the way how can we solve the this question. So let's see the third question in this. Let's see the third question. So how to find out A complement intersection B complement, that they are given the question. So the question is, let U is equal to 1, 2, 3, 4, 5, 6 and A is a subset of this one 2, 3 and B they are given 3, 4, 5. Then A complement intersection B complement. So let's see how to solve. So first let's find out the A complement. A complement is the U minus A. That means 1, 2, 3, 4, 5, 6 minus 2, 3. So here 2, 3 cancel in both. So we'll get A complement as 1, 4, 5, 6. So this is the A complement. Next we will find out B complement. So B complement is nothing but U minus B. So U means universal set. 1, 2, 3, 4, 5, 6 we have universal set. Minus B we have 3, 4, 5. So this 3, 4, 5 is cancelled in this. So we'll get B complement as 1, 2, 6. 1, 2, 6. So now we have to find A complement intersection B complement. So that is A complement we got 1, 4, 5, 6. Intersection B complement we got 1, 2, 6. So what is the intersection of these two? What is the intersection of these two? 1, 6 is the common elements in both. So 1 we have, 6 we have in both. So A complement intersection B complement is 1, 6. So this is the way how we can find solution for this question. So let's see next question. Simply how to find A delta B. One more question we have, but that I will give as a homework. Let's see another question. If A is equal to 8 power n minus 7n minus 1 such that n belongs to natural numbers, and given B is equal to 49 into n minus 1 such that n belongs to natural numbers, then means here they are given the options. A is a subset of B, B is a subset or equal to A equal to B, A is a subset or equal to B. So this is the options they are given. So let's find out what is the set A and set B first. So set A, what they're given is 8 power n minus 7n minus 1 such that n belongs to natural numbers. So first what I will do is, yes, n belongs to natural numbers they told. N belongs to natural numbers means n starts from 1, 2, 3, so on like this. So I will substitute this n values in this at least 1 or 2 to 3. So if I'll substitute n is equal to 1, I'll get 8 power 1 minus 7 into 1 minus 1, which is 0. So when I'll substitute n is equal to 2, 8 square minus 7 into 2 minus 1, 64 minus 15, which is 49. So if I'll substitute n is equal to 3, so 8 cube minus 7 into 3 minus 1, which will get 490. So what is our set A is here? 0, 49, 490 and so on. So let's see about the set B. Set B, what they are given is 49 into n minus 1 such that n belongs to natural numbers, such that n belongs to natural numbers. So when I'll substitute n is equal to 1, it will be 0. N is equal to 2, it is 49. N is equal to 3, 98 and so on. If I'll substitute n is equal to 11, it will be 490 and so on. So if you'll observe clearly, all the elements of set A are there in the set B. So we can take like A is a subset of B. A is a subset of B. So here which option is correct in this? So option A is correct in this question. So let's see the next question. So next question is, if n of u is equal to 700, n of A is equal to 200, n of B is equal to 300, n of A intersection B is equal to 100, then n of A complement intersection B complement is equal to. So option A given 400, option B is given 240, option C is given 300, option D is given 500. Option D is given 500. So let's see how to solve here this question. So what they are given is n of u value they are given, n of A value they are given, n of B value they are given, n of A intersection value they are given. So n of A complement intersection B complement they are asking. So what we know, the n of A complement intersection B complement, n of A complement intersection B complement is, we can write like n of A union B whole complement. So this we can write like n of u minus n of A union B. So n of u value we know 700 minus n of A union B we can find out from the given remaining values, that is n of A plus n of B minus n of A intersection B. So this is the formula to find the n of A union B. So 700 minus 200 plus 300 minus 100. So that is equal to 700 minus 200 plus 300, 500 minus 100, 400. So we will get n of A complement intersection B complement. Therefore, n of A complement intersection B complement is equal to 300. So this is the way how we will find the value of A complement intersection B complement. So let's see the another problem based on the same topics. So next question. If n of u is equal to 48, n of A is equal to 28, n of B is equal to 33, and n of B minus A is equal to 12, then n of A intersection B complement is. So how can we find this one solution? Let's see. N of A intersection B complement, in the sense they're asking for n of u minus n of A intersection B. So n of A intersection B, how can we find this? N of A intersection B will be diagrammatically from the Venn diagram. We will see n of B minus n of A n of B minus, here let's see the diagram first, how we will find out this one. So let's see. So if this is a Venn diagram, universal set, and this is a set A, and this is the set B we have. So this is the set B. Okay. So what they're given is B minus A they're given. B minus A means this only, no? This is the B minus A. So this is the B minus A. So this B minus A, how can we write is, from the total n of B, from the n of B, if we'll subtract n of A intersection B, you will get n of B minus A. So n of A intersection B. So from here what we are understood, so n of B minus A is 12 they are given, n of B is 33 they are given, minus n of A intersection B. So from here n of A intersection B is equal to 33 minus 12, which is 21. So let's substitute that here. N of U is 48 minus n of A intersection B is 21. So therefore we will get n of A intersection B whole complement is equal to 27. So this is the answer for this question. So here is one more question, that is, if n of A intersection B complement is equal to 5, n of B intersection A complement is equal to 6, n of A intersection B is equal to 4, then the value of n of A union B is. So let's see how to find out this one. So from the given information, n of A intersection B complement in the sense, this is n of A minus B, which is 5. And another one they are given B intersection A complement. That means n of B minus A, which is 6. And they are given n of A intersection B, that is equal to 4. Asking to find n of A union B. So let's see by using the Venn diagram. So let's take this is our universal set. This is our universal set, and these are the our set A, and this is our set B. This is our set B. So let's see now what they are given. So this is a set A, this is set B. A minus B value 5 they are given. A minus B in the sense this yellow colored one is A minus B. This is what they are given. This is what they are given. So A minus B. So this is what they are given 5. This is they are given 5. B minus A. B minus A in the sense this circle. This is the B minus A. So this is the B minus A. B minus A. So how much they are given? B minus A. So B minus A they are given 6. And A intersection B means this part. This is they are given 4. So if I want A union B is nothing but this yellow color, this blue color, and this A intersection B, right? So n of A union B is n of A minus B plus n of B minus A plus n of A intersection B. So diagrammatically we understood easily. So 5 plus 6 plus 4, which is 15. So this is the way how we will find out the values of this all. So I'm giving some homework questions here. So please solve the questions. So for the solutions, please watch the part 2 of sets. These are the homework questions. Please solve these questions. Thank you all for watching my videos. Please subscribe, like, and share. Thank you all.